Have you ever wondered how GPS works? How does your smartphone know exactly where you are any time of the day? It's a question that often goes unanswered, but today we're going to shed some light on this fascinating technology. GPS, or Global Positioning System, is an integral part of our daily lives. It's like our invisible guide, helping us navigate through unfamiliar territories, tracking our morning runs, and even aiding in search and rescue missions. Behind the scenes of this remarkable service is an intricate network of over 30 satellites, all orbiting the Earth. This celestial fleet is the backbone of GPS, and it's what makes all those services possible. These satellites far above in the sky are in constant communication with our devices here on Earth. They're working tirelessly day and night to ensure we know exactly where we are and where we're going. But how does your device tap into this satellite network to pinpoint your location? Well, let's dive deeper. It all starts with the satellites. These are not just any satellites, they are GPS satellites, specifically designed for this purpose. They are our eyes in the sky, tirelessly orbiting the Earth twice a day. Each one of these satellites carries an incredibly precise atomic clock that keeps time down to a billionth of a second. Now, imagine about 24 of these satellites, spread out in space, each one constantly broadcasting a signal. This signal is like a beacon in the night, sending out the satellite's unique identifier and the exact time the message was transmitted. Your GPS receiver, whether it's in your car, your phone, or your smartwatch, picks up these signals. The time it takes for the signal to reach your receiver is key. After all, speed equals distance over time, right? Using the timestamp from the satellite signal, your GPS receiver can calculate how far away the satellite is. So we've got our satellites broadcasting signals, but how does that translate to a point on a map? This is where the Earth-based stations come into play. These stations are the unsung heroes of the GPS process. Stationed strategically all over the world, these monitoring stations have a vital task. They keep a close watch on the signals broadcasted by the satellites. But why, you might ask? To ensure absolute accuracy, of course. You see, while our satellites are impeccable timekeepers, even the tiniest discrepancy can lead to significant errors in location data. This is where our Earth-based heroes step in. They monitor and correct any minor errors in the satellite's atomic clock. This corrected information is then relayed back to the satellites. But that's not all. These stations also take into account factors like atmospheric conditions, which can affect the speed of the satellite signals. These corrections are included in the signals that the satellites broadcast back to Earth. So we have our corrected signals, but how does your smartphone use these signals to pinpoint your location? Your device with its built-in GPS receiver is the final piece of the puzzle. This tiny marvel of technology is what interprets the signals sent by at least 4 satellites. Now, why 4 satellites, you ask? Well, each satellite provides one piece of a 4-dimensional puzzle. 3 for the device's location in space, and 1 for the exact time. The GPS receiver measures the time it takes for each signal to reach it. Given that these signals travel at the speed of light, even a millisecond of difference in arrival times can translate to a significant change in distance. By comparing these time differences, the receiver can calculate the device's exact location. It's like a cosmic game of hot and cold. But instead of you're getting warmer, it's you're 345.6 kilometers from this satellite. So that's how your device knows where you are. But let's quickly recap how this all works together. GPS is a marvel of technology that we often take for granted. It's like a vast invisible highway system that spans the globe, enabling us to pinpoint our location with astonishing accuracy. The journey begins far above us, with satellites broadcasting a signal that travels at the speed of light, covering vast distances in the blink of an eye. But that's only the start. Back on Earth, Earth-based stations play a crucial role in correcting this signal, accounting for factors like atmospheric delay and satellite clock errors. This corrected signal is then broadcast back into space, completing a round trip that can span tens of thousands of miles. Then comes the final leg of the journey, our devices. Using this corrected signal, they calculate our precise location. This three-part relay from satellite to Earth station to your device happens in an instant, all to help you find your way. So next time you use your GPS to navigate, remember the intricate process happening behind the scenes to guide you on your journey.